I'm here with Paul Dalgleish, the Managing Director and Chairman of Greenhy2 with ASX ticker code H2G. The company recently went through a renaming and ticker change and was previously known as Tempo Australia. Thanks for joining me, Paul.
Yeah, hi.
We'd like to just jump into the specifics around the technology today, as it is quite special and it is something that would take a bit of an education process for everyone to understand how it works. Do you mind giving us an overview specifically of how the metal hydride solid-state hydrogen storage system does work?
The technology has been around for 50 years to store hydrogen in a metal hydride. It's really the type of hydride that we're using these days that's changed. And we have a very sharp competitive edge because we use a ferrous titanium hydride. And so what we do is we store hydrogen, instead of as a gas, we store it as a solid. Storing hydrogen as a gas is okay, but you just have to store at very high pressures to get a decent volume of gas and a decent amount of electricity stored. Whereas we store it as a solid, and the solid is at least 5 times denser than hydrogen gas at 500 bar, so at very, very high pressure. So the high pressures are suitable for, say, the refining industry, not that suitable for the electricity industry. So this solution is at 40 bar. It's a very safe pressure. It's solid, so it's safe. It's at ambient temperatures. And so how it works is that we go through an electrolyser from a renewable energy source, such as solar or wind or hydro. We come in through the electrolyser. It produces hydrogen as a gas. We put that into the metal hydride. It produces the gas from the electrolyser at 40 bar, and it goes straight into the hydride at 40 bar. So there's no compression, there's no pumps or rotating equipment, expensive rotating equipment. It goes into the metal hydride, stores as a solid, and then when we want to make electricity, we open up the other side of the vessel and we come out at 2 bar and go straight into the fuel cell. So again, no repumping, no compression cycle. It's a straight chemical reaction. The electricity that's made then goes off through a fuel cell off to the load. So the ability to store it as a solid is the IP. The technology partner we use is a company called GKN out of Europe. They've been working in this area for 10, 15 years. It's a very commercial product. It's not experimental, and it's been developed for the last 10 to 15 years. The other side benefits are that it doesn't degrade. It lasts forever if you just lock the vessel up, and it'll keep the storage. It doesn't reduce its capacity to store like a lithium battery or any other normal battery system. It is 30-year life. We guarantee over 20 years. And it's 100% recyclable at the end of the day. So the technology it's quite simple if you like, but there's a lot of IP in there. Keeping the metal lattice as a structure is quite advanced, and that's GKN IP. And putting the system together in an integrated system is, of course, our IP. So between us, we're able to deliver this product, and we've got a demonstrator unit in with Essential Energy that's operating off-grid and has been for the last 6 to 8 months.
Yeah, great. And just jumping back to the ferrous titanium hydride specifically, can you give us a brief outline of how that compares to other metal hydrides available on the market?
There's very few commercial metal hydrides available on the market. Lanthanum nickel was the original workhorse of the metal hydride industry, and it was used for compressors. It's quite an expensive hydride. It's quite a good one, but it's an expensive hydride and is not practical for this solution. Most of the other hydrides work at very high temperatures or have some magnesium or something in it, which is not as safe as a ferrous titanium hydride. So at the moment, from a commercial point of view, we've really got probably the only commercial metal hydride for power production in the world.
Yeah, great. So safe and economic would be the 2 takeaways.
Yeah.
Yeah, great. And I think something else that we'd like to touch on is the IP in the actual digital platform and user interface that comes along with the system that customers can use. Do you mind outlining a little bit of that?
Yeah, so the digital platform that comes with it is very advanced. So GKN provide support on that side of the package. They are very advanced in that area from their manufacturing processing heritage. We are able to look at our units anywhere in the world. We're able to service them and maintain them as well remotely. We're able to run simulation models for them both going forward and forecasting. We have AI that updates the simulation models and uses machine learning to match the simulation to the actuals. And then that gives us the capability to run what they call a digital twin, where we can run a digital model of the unit and we can look for variances to real world conditions and see, okay, maybe it needs some maintenance, or is it varying for a good reason, say less sun, or does it need some servicing? So we run a digital twin in the background. It's quite advanced technology, but it's what will be required by these big utilities who will be our customers, such as Essential Energy and Ergon and those people. They want to be able to monitor thousands of these units and have it all remote and have it simple and also self-diagnostic.
Yeah, great. And also just to outline what the application would be for this system in the market at the moment, you're looking at standalone power supplies. For anyone who isn't familiar with that, could you explain how standalone power supplies work and how they service a key part of the Australian market?
So all of the utilities in Australia have a process of taking uneconomical users off grid for a number of reasons. For many of them, they are in a place where they get unreliable supply. Part of that is due to our bushfires, part of it's due to our floods and cyclones, part of it's due to the long lines that run into them and that they can cause bushfires, and then they have to be replaced. And so that leaves them with diesel solutions for a lot of them. Of the big customers, like Essential, 1% of their customers cost 17% of their grid costs. I've heard Western Power quote 1% of their customers can cost up to 50% of their grid costs. For the other Horizon and people like Northern Territory Power and Water, their grid costs are a lot higher than like an urban area. And so what they want to do is they want to take these people off grid or make microgrids for, say, Indigenous communities. And so if you're going to take people off grid, you need to be able to guarantee them power all year round. The only way we can do that at present is to give them diesel backup. If we go onto solar or we go onto wind. In our system, we can put the very large high-density batteries in, and they last for 30 years and fully recyclable, and then we can take the community or the user off grid. One, they lose the transmission line, which is good because they can't cause bushfires with it. It doesn't get burned down. They don't have to maintain the easement. So there's all these other advantages. Silent. So it makes no noise. So again, in country areas where that noise travels a long way, or Indigenous communities where that noise travels a long way, they don't have that issue. It sits there, it runs off solar, it's fully renewable, and the actual operating costs are extremely low because they don't have to pay for power anymore. So, and no one's flying in diesel in flood times. So it's massively advantageous for them. So that's the goal, and they've all got a program of taking users off grid to benefit and as a benefit, and so we're going to be part of that program.
I think it speaks volumes to the viability of the technology on the market that you have, given that you've actually got trials with these utilities at the moment, and they've also got significant programs underway for standalone power supplies.
They've all got future programs for standalone power supplies of some description.
Yeah, great. And I think something else that's worth mentioning is the fact that standalone power supplies aren't the only application for this technology. Could you give us an overview of what it could look like in the next 5 to 10 years as you move along in this process?
Standalone power supplies are the low-hanging fruit at the moment because they're going to be the most economical and competitive for our technology. So that's where we're targeting. And all forms of diesel replacement, of course, we're going to be far more competitive than diesel. So those are our low-hanging fruit at the moment. That's a massive market to start with. So we'll go into that first, and then we'll look at the rest of the market. Then we'll move into other areas, microgrids, and there's also a large market for depots and warehouses where they're going to put solar on the roof and then store their excess energy if they have it during the day, and then run their operations during the night. And we're also seeing large inquiries for people wanting to store daytime solar to run car chargers at nighttime, and that can be for smaller facilities, or it can be for quite large depots where they park a lot of cars overnight.
Yeah, great. Thank you very much for that, Paul. It's really exciting to think about what the possibilities are in this space.
My pleasure.
For anyone who'd like to learn more about the technology or about